Okay, the Pythagorean theorem is used anytime you have a right triangle. First off, it has to be. And in a right triangle, if you have two side lengths, you can actually find the third side length using the Pythagorean theorem, which we know is a squared plus b squared equals c squared. Now, when I work these problems, I work them a little bit different. I like to work with scaled triangles. I like to, if there's a number that'll divide into both of these sides, I like to shrink the triangle down. Like in this case, both of these are divisible by 5. So what I'll do is I'll divide each of them by 5, and I'll work with smaller numbers. Then I'll perform the Pythagorean theorem on this. Just make sure that you understand that the hypotenuse, which is across from the 90-degree angle, is always your c value. So we're going to plug in 1 and 2 for a and b. So we have 1 squared plus 2 squared equals c squared. This cleans up into 1 plus 4, which is 5, equals c squared. And to remove that square, we square root. So this missing side length will be root 5. However, we do need to remember that we shrunk this by a scale factor of 5. So in order to find this missing side length, we'll take our root 5 and simply multiply it back by that 5, and that's giving us our missing side length. Another example. Okay, in this next example, notice that now we're actually given the hypotenuse and we're missing one of the legs, which will work slightly different. So 6 and 14 are both divisible by 2. So our very first step is I would divide each of those by 2. It gives me 3 and 7. And just again, make sure that your c value always gets plugged in for the hypotenuse. So in this problem, we've got 3 squared plus b squared equals 7 squared. Now the only step that's different here is as we clean it up, we're going to move our 9 over with our 49 by subtracting. So we now have b squared equals 40. So b is going to equal the square root of 40, and we do need to clean that up. So the square root of 40 from earlier videos, we know we can split into root 4 times root 10. And since I know the square root of 4, we bring it out, and that's going to be 2. So our missing side length is going to be 2 root 10. But again, remember, since we scaled it down by dividing by 2, we're now going to take this and multiply back by 2. And in order to multiply 2 root 10 by 2, we're simply multiplying the 2 by the 2, and that's going to give me 4 root 10, which is the missing side. Now, there's certain triples that anytime we run up on that we need to have memorized. And let me show you some of those triples that I would commit to memory. The first one, the easiest one being a 3, 4, 5 triple, a 5, 12, 13 triple, a 7, 24, 25 triple, and an 8, 15, 17 triple. Now, here's how these triples work. Like if I were given, let's say, a 6 and an 8 for two sides of my triangle, when I reduce it by dividing by 2, that gives me a 3 and a 4. Then I notice right off the bat that if my two legs are 3 and 4, my hypotenuse must be 5. That's simply a memorized answer that I have. And since we divided by 2, I will now multiply back by 2, and that tells me that this final side length is going to be a 10. So these are practically just answers that you're memorizing that appear so often that it's something good to commit to memory. Next up, we're going to find the distance between 2 points. And one way of doing this is with what we call the distance formula. However, there, in my opinion, is a little bit much easier way to do this. So if we're wanting to know the distance from 3, 5, and I'm going to go ahead and plot these, 1, 2, 3, 1, 2, 3, 4, 5, and then 5, 9 would be somewhere up here. So in order to find the distance between 3, 5 and 5, 9, again, we're looking for this distance right here. To me, the easiest way of doing that is to imagine it as a right triangle. And if we could find the distance from 3 to 5, that tells us the bottom side of our right triangle. And the distance from 5 to 9 tells us the top side of a right triangle. And then instead of actually using the distance formula, which is just derived from the Pythagorean theorem, we can just use Pythagorean theorem itself. Again, we simply found the distance from 3 to 5. That gave us one length. The distance from 5 to 9 is the other length. And then we're going to use the Pythagorean theorem on that. Again, what I like to do is I like to shrink the sides. Instead of using 2 and 4, using 1 and 2, and find that missing side, and then scale it back up. So then we have 1 squared plus 2 squared equals c squared, or 5 equals c squared. To get rid of a square, we square root. So the square root of 5 is going to be the missing side there, but then once we scale it back up by multiplying back by 2, we find the distance between those 2 points is 2 root 5. Now let's try to work one more example, and I'll just make up one right here real quick. -3, 8, up to -6, -1. Again, first step, we find the distance from -3 to -6. And you can think of that on a number line as how far is it between these two numbers, and that's simply a distance of 3. How far is it from 8 to -1 would be a distance of 9. And again, we're trying to find that c value. Again, if you will shrink those values down by dividing by 3, gives you a 1 and a 3, and we're finding that missing value. Applying the Pythagorean theorem, a squared plus b squared will give you a value of 10 equals c squared. To undo a square, we square root, which gives me a missing side length of 10. Once I scale that back up by multiplying back by 3, we find the distance between these 2 points is 3 root 10.